Fact: the human brain repeats thoughts to reduce energy use and strengthen neural pathways. This is not a flaw in our thinking. It's a fundamental feature of how our brains are designed to operate. Have you ever noticed the same thought, worry, or idea looping in your mind? This experience, common to everyone, is a direct result of the brain's relentless drive for efficiency. To understand this phenomenon, we need to look deep into the intricate network of our neurons and the basic principles that govern their behavior. Our brain, despite being only about 2% of our body weight, consumes roughly 20% of our total energy. This makes energy conservation a top priority. Every thought, every action, every sensation is a process that requires energy. So how does the brain manage this incredible energy budget? One of its most effective strategies is automation through repetition. In the next few minutes, we will explore the science behind why our brains automatically repeat thoughts, examining the mechanisms of neural pathways, synaptic reinforcement, and the formation of cognitive habits. We'll uncover how this process, while sometimes leading to unwanted repetitive thoughts, is ultimately a testament to the brain's remarkable adaptability and efficiency. Let's start with the concept of cognitive efficiency. Think of the brain as a massive, complex city with roads connecting countless destinations. When you travel a new route for the first time, it requires focus, attention, and effort. You might need a map, and you'll likely drive slowly, consuming more fuel. However, if you travel that same route every day, it becomes second nature. You learn the turns, the traffic patterns, and you can navigate it with minimal conscious effort, saving both time and fuel. Our neural pathways work in a very similar way. Each thought is a signal traveling along a specific path of interconnected neurons. When a thought is new, the brain has to forge a new connection or use a weak, less traveled one. This process is energy-intensive. It requires conscious attention and processing power from areas like the prefrontal cortex. But when the same thought is repeated, the brain begins to optimize. The neural pathway associated with that thought gets activated again and again. Each time this happens, the connection between the neurons in that pathway becomes stronger and more efficient. This is the brain's way of paving the road, making future travel along that route much faster and less demanding on its energy resources. The result is that familiar thoughts require significantly less mental energy to process than novel ones. The brain, by its very nature, prefers the path of least resistance. Repeating thoughts is a direct consequence of this fundamental principle of energy conservation. This process of strengthening neural connections is known as synaptic reinforcement, a cornerstone of a concept called neural plasticity. Our brains are not static. They are constantly changing and reorganizing themselves based on our experiences, behaviors, and, importantly, our thoughts. Imagine two neurons that need to communicate to create a thought. The gap between them is called a synapse. When a signal crosses this synapse for the first time, the connection is tentative. But with repetition, something remarkable happens at a microscopic level. The more frequently a signal is sent between these two neurons, the more efficient that connection becomes. The sending neuron, or presynaptic neuron, may release more neurotransmitters, the chemical messengers of the brain. The receiving neuron, or postsynaptic neuron, may become more sensitive to these neurotransmitters by developing more receptors. Over time, these repeated activations can even lead to structural changes, making the physical connection between the neurons more robust. This is the biological basis of neurons that fire together, wire together. Frequently repeated thought literally carves a deeper, more defined channel in the brain's neural architecture. This strengthened pathway becomes a default route. When a related trigger or cue appears, the brain automatically sends the signal down this well-established, energy-efficient path. The thought doesn't just repeat, it becomes easier and more likely to repeat in the future. This synaptic reinforcement is the engine of learning and memory, but it doesn't distinguish between a useful thought, like a new skill, and a persistent worry. The mechanism is the same. Repetition reinforces the pathway, regardless of the content of the thought itself. So, how do these repeated thoughts become truly automatic? occurring with little to no conscious intention. The answer lies in the formation of habit loops. A cognitive habit loop consists of three main parts: a cue, a routine, and a reward. Let's apply this to a thought. The cue can be anything: an external event, like seeing a specific object, or an internal state, like feeling a certain emotion such as anxiety. This cue triggers the routine, which in this case is the specific thought pattern that has been reinforced through repetition. The brain runs through this familiar neural circuit. The reward in this cognitive loop is often subtle. It's not necessarily a feeling of pleasure. Frequently, the reward is a sense of predictability or a reduction in cognitive load. By defaulting to an automatic thought, the brain avoids the energy-intensive work of generating a new considered response. It's a form of mental shortcut. For example, if you repeatedly worry about a future presentation every time you see a calendar reminder, that's the cue. Your brain learns to associate the cue with the routine of worrying. The reward might be a fleeting and ultimately unhelpful sense of having prepared for the worst-case scenario, or simply the brain's preference for a familiar mental state over the uncertainty of the unknown. Over time, this loop becomes so ingrained that the thought is triggered automatically by the cue, requiring no conscious effort. It becomes a mental reflex. This process of mental automation allows us to perform complex cognitive tasks, like driving a car, while holding a conversation. But it also explains why certain thoughts can feel so intrusive and difficult to control. They are not being actively chosen. They are being automatically executed by a well-trained neural habit loop. The brain's preference for familiar patterns is another key reason for repetitive thinking. Our world is overwhelmingly complex, and our brains are constantly bombarded with sensory information. To make sense of it all without being completely overwhelmed, the brain relies on pattern recognition. It builds internal models of the world based on past experiences. These models allow it to predict what is likely to happen next, saving it the trouble of analyzing every new piece of information from scratch. Familiar thoughts are simply a part of these established mental models. They represent known territory. When the brain encounters a situation, it quickly searches for a matching pattern from its library of experiences. Activating a familiar thought pattern is quicker and safer, from a processing standpoint, than generating a novel response to an ambiguous situation. This creates a powerful cognitive bias toward the familiar. Even if a repeated thought is negative or unhelpful, it is still known. The brain often prefers the certainty of a familiar negative thought over the uncertainty and cognitive effort required to develop a new, more positive one. This is why it can be challenging to break cycles of worry or self-criticism. These thought patterns, however undesirable, have become deeply embedded, comfortable roots for our neural activity. They are the brain's default setting, chosen not for their content, but for their efficiency and predictability. The repetition is a feature of a system that prioritizes stability and energy conservation above all else. Understanding this preference helps explain why changing our thinking patterns requires conscious and sustained effort. It involves actively working against the brain's powerful, innate tendency to stick with what it already knows. Let's now visualize this entire process. Picture a vast, dark landscape representing the unmapped potential of your brain. Every new thought is like a single person walking across this landscape with a faint lantern, creating a temporary, barely visible trail. If that person walks the same path only once, the trail quickly fades, overgrown by the surrounding wilderness. But if a group of people begins to walk that same path every day, their footsteps compact the earth. The trail becomes clearer, wider, and easier to follow. Soon it's no longer just a trail, it becomes a well-worn road. Grass and weeds no longer grow on it. Now anyone traversing this landscape will naturally be funneled onto this established road because it's the easiest way to get across. This is what happens in your brain. A fleeting thought is the single walker. A repeated thought is the group creating the road. Synaptic reinforcement is the process of compacting the earth, paving the road, and making it permanent. Once the road is built, neural traffic, your thoughts, will naturally flow along it. This is automation. The brain doesn't have to expend energy creating a new path every time. It simply uses the existing superhighway. This analogy highlights how repetition, reinforcement, and automation work together. It also shows why some thoughts become so dominant. They aren't necessarily more important or true. They are simply the thoughts that travel along the most developed, most energy-efficient neural highways in our brain. The system is designed for efficiency, and these superhighways are the ultimate expression of that design. To summarize, the automatic repetition of thoughts is not a sign of a malfunctioning mind. It is a core feature of a brain that has evolved to be incredibly efficient. This process is driven by several key factors. First, the brain's need for energy efficiency encourages it to reuse existing neural pathways rather than creating new ones, as this conserves precious metabolic resources. Second, the principle of neural plasticity means that every time a thought is repeated, the synaptic connections that form its neural pathway become stronger and faster. This is synaptic reinforcement, where neurons that fire together wire together, making the thought more likely to occur in the future. Third, these reinforced pathways form cognitive habit loops, where a cue automatically triggers a thought routine, creating a mental reflex that operates with little conscious oversight. And finally, the brain has an inherent preference for familiar patterns and predictability, often choosing a well-known thought, even a negative one, over the cognitive effort required to process something new. Together, these mechanisms create a system where repetition leads to automation. This allows us to learn, form habits, and navigate our complex world without being constantly overwhelmed. The looping thoughts we sometimes experience are a direct consequence of this brilliant energy-saving design. If you find this interesting, like the video and subscribe to the channel Just Fact for more science-based facts.